Hello everyone, welcome to this video. In this video we shall be learning what is the sum of square of first n natural numbers. So that means if you take the first n natural numbers, square each of them, so you would have 1 square plus 2 square plus 3 square up to n square. What would be this sum? Do we have a particular formula for it? Yes, we do. Why it is important to have such formulas? Because you see this kind of series here is not making any particular form, right? It is not an AP, right? It is not an arithmetic progression, arithmetic series, and it is not a GP as well, right? Because we do not have a common difference which is constant, and also we do not have any common ratio which is constant in this particular case. So here they say we have the formula in order to calculate this kind of sum, and it is given by this n plus 1, 2n plus 1 divided by 6. This is the formula. So how this formula came into existence? So should we take an example? Let's take n is equal to 3. When n is equal to 3, our left hand side is 1 square plus 2 square plus 3 square. So it is 1 plus 4 plus 9. So it is equal to 14. What would be your right hand side? Your right hand side would be, we are taking n as 3. So it is 3 plus 1, 2 into 3 plus 1, right, divided by 6. So it is equal to 3, 4 into 7 divided by 6. So you would have this as 2, this as 2 here. So the answer is again 14. So you see your left hand side and right hand side, both they are equal to each other. Hence we have this result true for n is equal to 3. Now this is just an example, but we wanted to prove it for all the natural numbers. So let's proceed by a formal proof. So we will prove this result by the principle of mathematical induction. For the principle of mathematical induction, we are first required to prove the result for n is equal to 1. So when n is equal to 1, your left hand side is nothing but 1 square, right? And your right hand side is we will substitute n is equal to 1. So we would have 1 plus 1, 2 into 1 plus 1 divided by 6. Here, the value becomes 1. So now let's first of all solve the right hand side here. So solving this right hand side, we have 1 as the answer. And you see in the left hand side, we just have 1 square, which is 1. Hence left hand side and right hand side, both they are equal to each other. Hence the result is true for n is equal to 1. Now what about the second part? In the second part, what we do, we assume that the result is true for n is equal to k, right? So we take this series up to k square. So 1 square plus 2 square plus 3 square and so on up to k square. This would be equal to, here in place of n we will substitute k. So it would be equal to k plus 1, 2k plus 1 divided by 6. So this is what we have, and we are assuming that this thing is true, and we will make use of this particular equation in the third part. In the third part, we are required to prove the result for n is equal to k plus 1. For n is equal to k plus 1, we have our result as 1 square plus 2 square plus 3 square up to so on, k plus 1 whole square. This would be equal to, now here instead of n, we are now taking k plus 1. So our term would become k plus 1, right? This n would become k plus 1. N plus 1 would become k plus 1 plus 1, which is k plus 2, right? And 2n plus 1, it would be 2 into k plus 1 plus 1. So how much would it be? It would be 2k plus 3, right? This whole thing would be this, the whole divided by 6. So we wanted to prove that this thing is equal to k plus 1, k plus 2, 2k plus 3 divided by 6, right? So we first of all take this right hand side, and this right hand side is this one. Now let's take the left hand side and try to prove it equal to right hand side. So when you take this left hand side, you see the first k terms are nothing but your second part. So the assumption that you made in the second part here is what? It is given by this particular formula. So that you have k plus 1, 2k plus 1 divided by 6 here, correct? So you have k plus 1, 2k plus 1 divided by 6 plus k plus 1 whole square, right? So here you can clearly see you have k plus 1 and k plus 1 in both the terms, so you can take it as common. So you are left with this these terms k by 6 into 2k plus 1, right? And 1k plus 1 is left over here, right? Next, you can take the LCM here. You can take 6 outside and take the LCM, and you can multiply the terms here. It would become 2k square. It would become k, right? And here you will multiply by 6. So it would be 6k plus 6. And then you can simplify the terms. When you simplify, you have 2k square. K plus 6k becomes 7k plus 6 as such. Now what you can do, you can factorize this particular quadratic equation. So when you factorize this one, you would have the factors as 2k plus 3 and k plus 2. So exactly this is what you wanted to prove here in this particular case, which is your right hand side, right? So this is how we prove the result using the mathematical induction. Actually,